All right, so moving on from the general classification of all reptiles, we're going to move into the specific classification. So under class Reptilia, we have order Testudines, sometimes referred to as the chelonians. Chelonia are what you would probably know as tortoises or turtles. It's about 225 species in this group, characterized primarily by a bony shell, limbs that attach inside of the ribs, and a keratinized beak rather than teeth. So I mentioned that keratin was a protein often seen in this group, and it will show up again in some of the later vertebrates as well. Turtles are the primary example of this group. Again, note the shell is on the outside of where the limbs attach. That's fairly unique for this group. So here is a breakdown of what that looks like on the inside of the shell. You can see that there are two parts to the shell. The back part, the part that's on top, is called the carapace, and it is actually fused with the vertebrae. It's made out of the backbone of the animal. Its ribs extend out from the vertebrae and are part of the carapace. There's a second part that extends off of what would be like the breastbone. It's called the plastron. That is the bottom part of the shell. And you're probably familiar with box turtles or some of the turtles that are native to this area that will pull their heads and legs back up into the shell. So you can kind of get the idea of what they're doing. They have this fused, bony, protective coating, and they can pull all of those exposed bits inside of that shell. The carapace is the dorsal portion of the shell, formed from vertebrae, ribs, and what's called dermal bone. If you look at it, you'll see little plate-like structures that kind of make up the exterior surface. Those are dermal bones. And the whole thing is covered by keratin. It has kind of a greenish brown look to it, and that is that keratin, which again is the same thing that we find. It's a component in our hair and fingernails. The plastron is the ventral portion of the shell. It's formed from the pelvic bones and, again, more dermal bones. You can see more plates of bone also covered by keratin, so it'll have the same sort of coloration, again, mottled yellow, green, brown colors. All right, the next group, rhynchocephalians. So the rhynchocephalians are not lizards. They look like lizards, but there are two extant species. This is in debate right now because some people argue that they are just members of the same species that just live in a different area. They are lizard-like. They look like lizards, but then again, so do many early amniotes. So when this group started showing up in the fossil record, everything kind of looked like this. Tails and short little legs, same kind of body plan, because we think they all evolved from fish. The rhynchocephalian that we know of, this tuatara, is known for having two rows of teeth that overlap on the top and then one on the bottom, so they kind of make like almost like a scissor joint that allows them to shear and cut when they bite. They have no external ears or ear holes, so they're kind of an anomaly, have some characteristics that make them stand out as different from lizards. Here is a short video clip of a tuatara eating, and maybe you can see a little bit of how its teeth overlap, the two rows on the top, one on the bottom. This guy is chewing on an insect. All right, so rhynchocephalians, these are some extinct rhynchocephalian ancestors. The name rhynchocephalia means beak head. The Pleurosaurus is what this guy is known as, is the extinct relative of the tuatara. So they were around back in the hundreds of millions of years ago during the early days of this group branching out from the rest of the reptiles. All right, so now order Squamata. This group showed up 150 million years ago, and it diverged into many groups. You're probably most familiar with them being called snakes and lizards. They are all squamates. So we'll talk about the two subgroups. Suborder Sauria. Anytime you see S-A-U-R in one of these names, we're talking about something that is lizard-like. Dinosaur means thunder lizard. While not lizards, they look lizard-like, and so we use that S-A-U-R to reference that. The lizards, about 5,000 species of them. They're known for two paired legs. Most of them are oviparous, meaning they are egg layers. There are some that are ovoviviparous, which means they have eggs, but they keep them inside of the mother till they hatch. Some are viviparous and give birth to live young, but most of them are egg layers. You're probably familiar with at least seeing eggs of lizards that are kind of soft and leathery, very similar to snake eggs. Geckos, iguanas are just some of the many examples of saurians. Suborder Serpentes, the snakes. So this group, also squamates, 2,300 species make up this group. They're elongated, they lack limbs, they have flexible vertebrae, and unhinging jaws for swallowing large prey. Most are ovips, I mean laying eggs, and a few are viviparous, meaning they give birth to live young. King snake, boa constrictor, python, rattlesnake, and of course everyone's favorite, the cobra, because of its bony hood that it extends out the sides of its head. So there's a lot of diversity in suborder Serpentes. Feeding and digestion. So how do these guys eat? Well, I mentioned that they unhinge their jaws, and you can see that this snake here on the left has unhinged its jaws, and it is able to fit food into its mouth that's larger than its head. The way that it does that is, you can see the skull picture here at the bottom. The jaw hinges in the back, and it actually is able to pop those bones apart, unhinge them so that it can stretch out, and the only limit then becomes the skin around the mouth, not the size of space between the bones. One more suborder, the suborder Amphisbaenins, or worm lizards. Hopefully you notice right away that this guy down here at the bottom looks an awful lot like the Gymnophionans, the Caecilians that we saw in our amphibian notes. It looks a lot like an annelid. It looks like an earthworm. So if you had to guess, where would these guys live? They're burrowing in the ground. They are burrowers. There are 135 species of this group. They are mostly legless. So a lot of times people will have trouble seeing something like a snake or seeing something like a worm lizard and saying, hey, how did this come from something that had 4 legs? Well, what we see is there are actually some transitional species that are still around today of Amphisbaenins that have little short projected limbs. You can see in the bottom picture on the left, there's one that has some limbs. Their skin have annuli. Remember, annelids comes from that idea of a repeating circular pattern, annual, like every year. So annuli are rings around this guy. They bulge out, they brace against burrow walls. These guys are predators that feed on worms and insects. They are ovips, they lay eggs. Now these are probably not likely to be encountered by most of us. I've heard some stories of some of these cropping up or being found near landing strips in some tropical areas where they're trying to build a landing strip for airplanes, and they have to move everything because they find one of a species of Amphisbaenins, and they're pretty rare. 135 species is not a huge amount of diversity. All right, so here is a little example video of an Amphisbaenin moving around. They are a little bit larger than earthworms or Gymnophionans, but again, a very similar body look, and they do that kind of extend, contract, wriggle that we saw in earthworms. All right, so now let's look at order Crocodilia. I also mentioned that crocodiles, the crocodilians specifically for the group, crocodiles being one member of order Crocodilia, were around during the time of the dinosaurs. There are 21 species of crocodilians that we know today. They come from the same Archosaur lineage, which you remember that was that branch of reptiles that is the same group that gave rise to the dinosaurs. They have openings on the skull in front of the eye. So got a sample skull. Unfortunately, I don't have one to show you here. All my stuff is at school. They have this extra opening in front of the eye that defines part of the group. They have laterally compressed socket teeth. So basically their jaw has little holes in them, and the teeth kind of fit into those sockets. They can't chew. So one of the things that they do is they swallow their prey whole. They will latch on with their teeth, and then they rotate to tear off swallowable chunks. So you may have heard of something called a death roll. It's called that because death rolls will usually kill the prey. They latch on, and then they start spinning because they can't chew and tear off a piece of meat, so they just spin until it tears off a piece. Crocodile hearts have an extra heart valve that can divert blood to the stomach. So they are very good at digesting food. Well, that happens to be good if you can't chew your food and you eat it whole pretty much, or big chunks of it. You have to break it down. They're oviparous, they lay eggs. Examples are crocodiles, alligators, and there are some that you're probably less familiar with, the caimans and gavials. We'll see some pictures of caimans and gavials to kind of let you know what those look like. So this is a short video of an entertainer that is working with this crocodile, and what they are trained to do is to put their hands inside the mouth of the crocodile, and when they do that, the crocodile will react by closing its teeth. And unfortunately, this fellow was a risk taker, fairly new at his craft, and he was doing this little activity, and he stuck his arm into the mouth, and this crocodile didn't cooperate the way that they normally do. This is a little bit graphic, so if you don't want to watch this part, you can skip ahead probably to the end of this video. But this is a good example of a death roll. You can see what happens when these guys latch on. If they latch on to part of something they want to eat, they will spin to tear off a chunk of that organism, or which food, I guess, and this unlucky fellow was doing this fairly not well-trained crocodile, who, again, not cooperating with him. And this is where he spins. And if you'll notice, the crocodile is spinning a lot more than the guy, which means his arm is getting twisted. Pretty gruesome. This would normally mean that the limb was ripped off. However, in this case, I did read up on this. They were able to get the crocodile to release his arm. He had severe breaks, and they were able to save his arm. It did not get torn completely off, but still pretty gruesome. So finishing up, here is a survey of crocodilians. We've got a crocodile at the top. We've got an alligator at top right. Both of those are common in this area, the east coast of the United States. We have some crocodiles that are farther south. Alligators are more common a little bit farther north. The gavial on the left, you can see, has that kind of skinny, elongated snout. Caimans look a lot like crocodiles, but they're much smaller. And if you have the question, what's the difference between a crocodile and alligator? How do you tell the difference? One of the ways that you can tell is looking at the teeth of the alligator. Notice that the alligator's teeth are very straight and orderly, and the crocodile's teeth kind of extend above and below the jaw in kind of a disorderly pattern.